Hello, I'm Mr. Valil, and I'm just a little guy, so please don't be mad at me, but today we're going to be talking about problem solving with quadratics, and don't be mad at me, okay, thanks. Oh, I'm sorry, you couldn't hear me. I'm so sorry, I'm so silly. Oh my gosh, please don't hate me, I'm so sorry. I said, hi, I'm Mr. Valil, and today we're going to be doing some problem solving using what we know about quadratic equations, and I'm just a little guy, so please don't hate me or be mad at me, okay? And please don't make me say it again, okay? I'm just a little guy, okay? Oh my gosh, okay, I'll say it one more time. I'm so sorry. Just please don't hate me, okay? Because I'm just a little guy. But today we're going to start using what we know about quadratics and using it to solve some problems using quadratic equations. And I'm really sorry, but I can't say it again. I just can't, okay? I'm just a little guy, so please don't hate me, okay? I'm sorry, I need you to be nice to me because I'm just a little guy, so please be nice to me, okay? Okay? Joke's on you, I don't care about what you think. It's problem solving time in class 9.5, problem solving with quadratics, part 1. So far, over the course of the past 2 units, we've used quadratic equations to build graphs, find solutions, and identify characteristics of our parabolas. But just like we did in Unit 4 with lines, we should be able to work backwards as well. All that to say, if we put that question down, flip it, and reverse it, now we want to ask, well, if I'm given information about a graph, or its solution set, or its characteristics, how can I use that information to my advantage to find the equation that produced them? There are 2 cases where we are likely to encounter problems like this. The first is when I tell you something about the vertex and something about a point on the graph. Here I want to build equations in vertex form. So take 30 seconds and look back at your notes. What the heck is the vertex form of a parabola? And once you've got it, take a minute, pause the video. How do you think knowing vertex form, knowing a vertex, and knowing a point on the graph could potentially be useful in generating the equation of our parabola? Take a risk, take a chance, take a minute, see what you come up with, and then we'll chat. Go! And stop. Well, my vertex form I need to know, this guy we know back from Unit 8, is y equals a times the quantity x minus h squared plus k. And the beauty and the power of this form is that from those horizontal and vertical translations, h and k, we in fact get the coordinates of our vertex. Well, hey, would you look at that? That means if I just need a, h, and k, I've already got an h from the 4 and a k from the -7 in the coordinates of my vertex. The only thing that I'm missing now is this guy A. But would you look at that, if I think about it, if the point 2, 1 is on my graph, doesn't that just mean that 2 is a specific value of x that corresponds to the specific y value, 1? Well, if I take all of that information and substitute in, look here, I've got 1 for y is equal to A, the thing that I need to solve for, times x, which we've identified as 2, let me do this in pink so it's all the same color, minus 4 for h, quantity squared, plus that -7 at the back. Now, I can do a bunch of simplifying. And when I do, we'll see that I actually can solve now for a. So inside of the parentheses, I hope you don't mind me writing that as -2, plus -7, let me rewrite as -7. My goal is to get a by itself. So using some inverse operations here, let me begin by adding 7 to both sides. This reveals that h is going to be equal to a times -2 squared, which I hope you'll agree is positive 4. Now, once again, my goal is to get a by itself. Dividing both sides by 4 reveals that a equals 2. And now I've got my a, I've got my h, I've got my k. I have everything that I need to build my equation, which should be 2 times the quantity x minus 4 for h squared plus -7, which we wrote as -7 at the back. Beautiful! Why don't you try this out on your own with part B? You've got a vertex and you've got a y-intercept. Think creatively about how you could use that y-intercept to your advantage and use that vertex and that point to build me an equation. Go! And stop. Well, we know -3 here is our h and -1 is the k that we need. From here, if -7 is my y-intercept, well, that just means that the point 0, -7 is on my graph. There's my x. There's my y. Let's slot into place. So here, using my vertex form, I've got negative 7 is equal to a, the thing I need to solve for, times x, which is 0, minus negative 3 for h squared, plus that negative 1 at the back. Simplifying, I've got negative 7 is equal to a times the quantity. 0 minus negative 3 is really 0 plus 3, which gives me 3 squared, plus negative 1, I'll once again write as minus 1. Now my goal is to get a by itself. Inverse operations, let's start by adding 1 to both sides. Negative 7 plus 1 is negative 6, and then I've got a times 3 squared. 3 squared is 9. Dividing both sides by 9 will get me a by itself, and negative 6 over 9 reduces to negative 2 over 3. From here, I've got my a, I've got my h, I've got my k. Substituting in, y equals negative 2/3 x minus h, so that would be x minus negative 3, which we'll write as plus 3 for the sake of space, plus negative 1 at the back, which we'll once again write as minus 1. Beautiful! Let's try a slight variation of this problem. Here, I'll tell you that you've got the vertex. You just might not know it yet. We'll try A together and do B on our own. Using what I've given you here, the fact that we have a maximum value and some x-intercepts, how could I use that to my advantage to find the coordinates of my vertex, a point on my graph, and thereby the equation of my parabola? Go! And stop. Well, you'll remember maximum and minimum are just fancy coded ways to talk about the y value of the vertex, which means that 8, if that's our maximum, needs to be the y value of our vertex, which here is k. For the x-intercepts, if I have the y value, you might remember that the x value of the vertex, due to the symmetry of our graph, lives right in the middle of those x-intercepts, which means if I want to find it, I just need to, take their average. So here, averaging 3 and 7 gets me 10 divided by 2, which is positive 5. There's the x value of my vertex. The last thing that I need is a point on the graph. Well, if I have my x-intercepts, I have 2 of them, right? I have the point 3, 0 from 3, and 7, 0 from 7 if I'm on the x-axis. Choosing one of them, maybe I'll pick the 3, 0 because its numbers are smaller and nicer and friendlier. I've got everything that I need to slot into place. So choosing that guy there, I've got 0 is equal to a, the thing I'm trying to solve for, times x, which we found was 3, minus h, which is 5, quantity squared, plus k, which is 8. Simplifying, I've got 0 is equal to a times the quantity, 3 minus 5, which is negative 2 squared, plus 8. Let's get a by itself by subtracting 8 from both sides. Negative 8 is equal to a times negative 2 squared. Negative 2 times negative 2 is positive 4. And dividing both sides by 4 to isolate a, we reveal that it's equal to negative 2. Taking this and slotting into place, I now know that y equals negative 2 for a, times the quantity x minus 5 squared for h plus 8 for k is my final answer. Try it on your own with B. You've got a minimum here, but that should still tell you something about your vertex. You've got your x-intercepts. Find me a vertex, find me a point, and find me an equation. Go! And stop. Once again, we know that this guy here, this negative 10, will be the y value of my vertex. To find the x value of the vertex, which we label h, I'm going to average my x-intercepts. So I've got negative 6 plus 4 divided by 2, which is negative 2 over 2. Negative 2 divided by 2 is negative 1. Same thing over here. I'm just going to pick one of these x-intercepts. Let's take the 4, 0 to use as my x, y. Slotting everything into place, that means that 0 for y should be equal to a, the thing I need to solve for, times the quantity 4 for x, minus h, which is negative 1, quantity squared, plus k, which is negative 10. Simplifying on the right-hand side, I've got 0 is equal to a times the quantity 4 minus negative 1, which is positive 5 squared, plus negative 10, let me rewrite as minus 10. Adding 10 to both sides here, I can get closer to my goal of isolating a. 10 is going to be equal to a times 5 squared, which is 25. And dividing both sides by 25 reveals that a is equal to 2/5. Taking that and slotting into place, I now know that my equation should be y equals 2/5 for a times the quantity x minus negative 1, which we can write more simply as plus 1 squared, plus negative 10, which we can write more simply as minus 10. Beautiful! There's our first case, given a vertex and a point. Our second case, rather than being told the vertex, I'm also likely to be told something about my x-intercepts, where my parabola crosses the graph, which we saw abstractly is the same as our solution set to our equation, equivalently called its roots, or its zeros. So say here that I take this equation, I want it in intercept form, which means I need to know what my intercept form is. I've got some x-intercepts and a point on my graph. Same thing as vertex form. Go back, find the intercept form for me, and then tell me how you think that knowing these characteristics could potentially be useful in generating my graph. Go! And stop. I lied, I don't care about a graph. I care about an equation, which here is in intercept form. Intercept form we might remember. We write as y equals a times the quantity x minus p times the quantity x minus q. And the power here, just like vertex form gives us our vertex, these guys give us two x-intercepts, p and q. Well, if my x-intercepts are at -2 and 5, that means that I've got some values of p and q. Same thing as before, -4 can act like an x for me, 6 can act like a y for me. If I take all of this and slot into place, once again, I should be able to solve for a. So let's do it. I've got 6 for y is equal to a, the thing that I need to find, times x, which we've identified as -4 minus p, so that would be -4 plus 2. And then I've got x, which we saw was -4, minus q, which would be -5. Simplifying here, I've got 6 is equal to a times -4 plus 2, which is -2, times -4 minus 5, which is -9. On the right, if I do that multiplication, -2 times -9 is positive 18. Last move is just to get a by itself. Well, a should be equal to 6 over 18, which reduces to 1/3. Slotting everything into place, that tells me that y equals 1/3 for a, x minus -2, which is really x plus 2, times x minus 5 is the equation of my parabola in intercept form. Beautiful. One last extension of this case and then you're free. Let's say now that I just give you some abstract solutions. Here, x equals 3 plus or minus √5 over 2 we'll do together, and then I'll set you loose on b. I want you to think strategically. What does this solution set look a lot like? Why do you think I've gone through the hassle of writing it for you in this form? And based on that, what tool do you think I'm going to use? Once you've got that tool, make a guess about how you think I'm going to use it. Take a risk, take a chance, see what you come up with, and then we'll chat. Let's do it. Alrighty. Well, 3 plus or minus the square root of 5 over 2, don't that look quite a lot like my quadratic formula? X equals -b plus or minus square root of b squared minus 4ac all over 2a. And if I notice that this looks a lot like the quadratic formula, I should also notice that the numbers correspond to specific slots or specific parts of that quadratic formula. Well, let me see if I can use that to my advantage here. Here, notice that -b, or the thing in the -b slot, is positive 3. So if negative b is positive 3, if I flip my signs, that tells me that b should be equal to negative 3. Interesting. How about the 2? Well, the thing in the 2a slot is 2. If I divide both sides by 2 to isolate a, that tells me here that a should be equal to 1. The last thing that I need to use to my advantage is that the thing in the b squared minus 4ac slot is 5. But I now know that b equals negative 3 and a equals 1. Hey, look at that. I can do some substitution. So I've got negative 3 squared for b minus 4 times a, which we identified as 1, times the c at the back is equal to 5. Just like I did for a above, now I can solve for c. So I've got negative 3 squared, which is positive 9, minus 4 times 1, which is 4, still attached to that c, all equal to 5. I want to get c by itself, so let's subtract 9 from both sides. Here, negative 4c is going to be equal to negative 4. Dividing both sides by negative 4 reveals that c is equal to 1. So now I know a, I know b, and I know c. I have everything that I need to slot into my standard form, which would be y equals ax squared plus bx plus c. Doing so, we know that a is 1, so I'll just write this as normal x squared. I know that b is negative 3, so there's negative 3x, plus c at the back, which is positive 1. Would you look at that? There is my equation. Try it out yourself with part B, and then we're done. X equals negative 1 plus or minus the square root of 113 all over 8. Go! Okay, once again, the negative 1 is in the negative b slot, the 8 is in the 2a slot, and the 113 is in the b squared minus 4a slot, or 4ac slot. Let's see what doing some substitution can reveal for us. So first of all, in the negative b slot is negative 1. Flipping both of my signs here reveals that b should be equal to positive 1. Same thing for 8, which is in the 2a slot. If I divide both sides by 2, that reveals that my value of a should be positive 4. Now, in the b squared minus 4ac slot is my 113, which seems scary, but if I do my substitution with those values of b and a that I've identified, I should be able to solve for c. So b squared is going to be 1 squared minus 4 times a, which we've identified as 4, times that c at the back, all equal to 113. Well, 1 squared is 1. 4 times 4 is 16, so this is minus 16c is equal to 113. Now to get c by itself, normal inverse operations, I'm going to subtract 1 from both sides to reveal that negative 16c is equal to 112. Dividing both sides by negative 16 reveals that c is equal to negative 7. So I've got a value of c, I've got a value of b, I've got a value of a. Slotting everything into place tells me that my equation should be y equals 4 for a x squared plus b, which is 1, so I'll just write this as invisible x, plus negative 7, which I'll write as minus 7 at the back.